Today we have a new video, and today we're gonna talk, like I already explained back on LinkedIn and on YouTube, about electric motors. There is a different ways approaching the electric motors, and you will see soon that we have here quite a few different modules. So on the one hand, we have our training system basically here, where we are simulating different states of the electric motor or different conditions more or less. And furthermore, we also have a real electric model here, which is just right beside me. So this model over here shows from an ID.4, Volkswagen ID.4, the front drive with a complete electric motor here as an asynchronous motor basically. But you see the complete unit, and later on we go exactly into more detail about this unit and about these modules. Then let's have a look at the modules which we have here. So we have quite a few. They look pretty different, but what is the big difference is about what's in the different modules. So the basic thing is you see our electric motor over here, and we have our real connection, like you would see it on a real engine basically. So this is just the ground connection. There is nothing like that on the real motor, but just to make sure that we have the ground connection over here. When we have a look at the real motor, you will see that this is exactly what we find here. So the different three connections from there, from the modules you see now here at the engine. And everything else around here, what is not painted, can be used as the ground connection. Then, when we have a look down here, we see there's a different way of connecting the different coils from the stator with each other. On the right-hand side, we have the star connection. So you see the different coils are connected as a star, where they have the star point in the middle. And on the left-hand side, we see the delta connection. So there, we don't have a star point because all the coils are connected here on this way with each other. The big thing about this one is you can't see from the outside if you have a delta or a star connection, and this just depends to the car manufacturer. So when we think about now what's the difference between delta and star, it's like you can't say that only one thing or one type is used in the cars. It's more like it depends on the whole strategy of the car manufacturer, what you do at the engine basically, or at the electric motor. So you can say when you have a delta connection that you can create more torque and more power. So electric motor in delta connection is just better for getting the maximum power and the maximum torque out of it. But on the other hand, the star connection, it guarantees that there is a smoother running of the engine, and it's just easier to do. So you don't need to worry too much about what's in the electric motor. It can either be the star connection or the delta connection, okay? And like I said, with the star connection, it consumes less power, but with the delta connection, you have a higher power output. And it just depends on the strategy of the car manufacturer, what they will establish in their car. Now let's have a look what we can measure at the electric motor. So, like I said at the beginning, today's topic is about thinking what kind of measurements we can do at the electric motor in order to find out if it's in good condition or if something is wrong with the motor. So, okay, let's have first a look what kind of measuring tools we need. And this is pretty basic. You see here on the right-hand side, it's our insulation meter. So the insulation meter basically, on the one hand, of course, it can go in a very high area, like you see it here in the mega ohm area, where we want to measure a really high voltage. And the voltages which you see here are depending on the system's own voltage. So for example, if you measure at the high voltage system, which has as a maximum voltage 800 volt, you have to use 1000 volt here. But if the system just have 400 volts, for example, you can use the 500 volt option. So that's on the one side for the mega ohm area, so for the insulation resistance. But if we take a measure on an electric motor, it's also interesting to measure the resistance of the coils basically. And they of course are not in the mega ohm area, but in a very, very low ohm area. And this is why we just go here, for example, to the normal ohm area in order to measure it. You just have to see how low your measuring tool can go. But this depends, like I said, on each individual measurement tool, and just make sure that the tool can measure this low area of resistance. So in the picture, now you see animation who will show you how the electric motor works, or more or less how the magnetic field, the rotating magnetic field, is created through or within the stator and through the three different coils who are controlled by the inverter. You see that all the different coils have a different or have a same sinus voltage regarding the amplitude, but there's a phase shift. And you have the first coil, the second coil, and the third coil. They are always with a gap or with an angle of 120 degrees. So everything together will lead to 360 degrees. And now you see with this arrow from the last animation how the rotating field is created. And this field, of course, attacks at the rotor and starts the rotor to spin. And it doesn't matter if it's a static or if it's an asynchronous or a synchronous rotor. So that doesn't make any difference. The stator always works the same. Now let's have a look when we just measure the normal resistance of the coils within the electric motor. So we'll, in order to make it a little bit easier, we will measure down here, at first at the delta and then at the star connection. So the multimeter or the insulation meter here has now also the low voltage measurement area. Not the low voltage, sorry, the low ohm or the low resistance measurement area. So this is perfectly good for us, and now we are checking what the resistance of these coils are. And I just do the measurement and you see it's pretty low, so it's below 1 ohm basically. And when we now go through the different coils here, you see we have, it always depending on, you see that there are different values, for example. But this